Hi everyone. So I'm looking here at example 6, which just precedes supplementary worksheet number 5. This is an example of a disproportionation reaction where the same substance is oxidized and reduced. I just put the right relevant oxidation states here. So chlorine is changing from 0 to +5 and from 0 to -1. So it's a little easier in these reactions to just repeat the substance that's been oxidized and reduced on the same side, just for the way we do the reactions in our method. Because remember that this number, the quantity of chlorine, is going to increase, so it's like I'm writing them separated, and then I rejoin them at the end. It just makes things a little easier. So I'm going to write Cl2 here one more time. And so now I can work with this chlorine, balance it, work with this chlorine, balance it, and at the end, just clean it all up. So Cl2 is going from 0 to -1. I have to pre-balance it because it's not currently balanced with a 2. And so now it's fine, and it's going, again, as I said, 0 to -1, that's 1 electron. But for 2 chlorines experiencing that change, it's 2 electrons for all the chlorine. 2 electrons gained. Okay, so it's a reduction. This chlorine, again, is 0, and in this scenario, it's going to +5. Again, it's not pre-balanced, and so I would need to put a 2 here. And so now I want to figure out the number of electrons. In this case, they're lost because the oxidation state is increasing. So it would be 5 electrons for each chlorine times 2, because there's 2 chlorines, 10 electrons lost. So I have a reduction and an oxidation. That's great. And so now I want to balance the electrons, and I'll do that by multiplying this by 5. So that 5 will transfer here, and here there's a 2 there, so 5 times 2, 10. Okay, so now what remains is just to balance the hydroxide and the water. So you may have recalled that in a previous video I said when you have to balance charge, or you're looking to balance by inspection rather, and something that's charged is present, try balancing charge first and then finish off with the inspection, because all reactions have to be balanced for charge, the left side and the right side. And so sometimes it's helpful to come up with that coefficient by balancing for charge first. So this whole side right now has a charge of -11. Sorry, I apologize. I was counting that chlorine on this side. -1. And this side is 10 times -1 is -10, plus 2 times -1 is -2, and 10, -12. So this side is currently -1. So if I put a 2 here, that's -12. It would have been very difficult to come up with that coefficient just by inspection. There'd be a lot of erasing and fixing and playing around. But look how easy that was. Now I just have to finish off with the water. And so we needed 6 here. 6 times 2 is 12. Let's just check the oxygens. 2 times 3 is 6, plus the 6 over there is 12. 12. Beautiful. Now the reason why the answer is 36513, which might look different than this, is if you group this 5 moles and 1 mole, that's really 6 moles of Cl2. It's not really, by convention, we have to write only the substance once on the reactant side or product side, as is the case, and then put the correct coefficient. So it would be 6 here for chlorine. And now you can see that you can reduce these coefficients by dividing by 2. This becomes 3, this becomes 6, this becomes 5, this becomes 1, and this becomes 3. And so that should now match the answer that you see there. Okay, so that's it. Thanks, guys.